Hello everyone, are we online now? So my name is Leo, I'm a developer, I'm based in Kuala Lumpur, Malaysia, and I'm working on a new plugin for WordPress, which is a GraphQL server. So it's going to be launched soon, actually in a few weeks from now. And this is the avant release. I'm going to show you now how it works. I hope that you'll actually like it. I hope that you'll actually say, I want to have this thing. So yes, welcome to my talk. It's called Introduction to the GraphQL API for WordPress. I'm going to share my screen only. Later on, we can actually have a Q&A, and if you have any question, you can ask me. So my talk is on slides.com. So if you actually go to the URL slides.com/leoloso/GraphQL API for WordPress, you can see the same slides as here. My Twitter account is Losoviz, like my surname, and my personal blog is leoloso.com. So first, what is an API? It is a mechanism through which the client can interact with the server. So we have a client, we request data, and the server will give us a response. That's pretty much what it is. So in the context of WordPress, what API do we have? We have first the REST API through the WP REST API, which is already included in the core in WordPress. And then we have GraphQL through the WP GraphQL plugin, which is on wpgraphql.com. They have not released the plugin yet, so we had to install it from GitHub. So how do they compare these two? The WP REST API has fixed multiple endpoints. The retrieved data corresponds to resources, and it operates via get, post, put, and delete operations. So the way that it works is that we do a get. In this case of WordPress, the URL will look something like wp-json/wp/v2/posts, and that will give us a list of posts, and the data is predefined. It's a big blob of information. How does it work with WP GraphQL? It has only one endpoint. The retrieved data matches the query, and it operates via post. So we write the query. In this case, we are querying for posts, and for each post, we want the ID, the title, and the URL. And when we run this query, we get exactly that. In this case, we have like 3 records, which is 3 posts, and for each of them, we have exactly those same fields, ID, title, and URL. So how do they compare these two? Concerning the speed, WP REST API is quick when you get only one call to one endpoint, but the problem is that you will need to fetch many different. You actually have to execute the request many times to fetch different resources. For each post, you might actually want to get the author of the post, and maybe you also want to get the comments. And for the comment, maybe you also want to get the author of the comment, and etc. So for each of them, you'll have to nest different requests, and it makes it very very slow, at least in mobile. WP GraphQL solves this issue because you're querying exactly what you need. So in just one request, you can get everything, all the data. Concerning security, WP REST API is very simple. Everything is just there. There's no way to mess it up really much. WP GraphQL, the problem is that it has a single endpoint, and then you execute the query to fetch the data that you need. So you're given a huge amount of access to anyone to execute any complex random query against your server and try to get whatever data they can actually find. So it's not so, I wouldn't say it's not secure, but you need to pay attention to security. And if you don't get it right, you can actually open up the gates to bad actors. Caching. WP REST API, it's because it has a URL, you can actually cache based on the URL. So then you can implement it on the server side. You can implement it HTTP caching. So caching is pretty well supported. WP GraphQL is actually pretty bad. If you want to implement caching, you need to do it on the client, most likely. Maybe you can do it on the server through hacks. Doesn't completely work well. So what that means at the end of the day is that you will have to request the data fresh each single time. Access control. So we want to limit what our users can actually see. If we want to say you can access the field email from the user or not, you have to have the certain permission. That is difficult to accomplish. It can be done, but it's not given to you by default. Simplicity. WP REST API is very simple. You just create and resolve that endpoint. WP GraphQL is a little bit more difficult because you are dealing with graph. You may not always be really worrying about about the graph. You know that you have to think in graph theory terms, but you need to worry about certain issues like avoiding the a problem called the n+1 problem, which is that you're fetching you're executing one query to the database per record that you need to fetch. It can be extremely ineffective, and you have to be aware of these things. So in that sense, it doesn't make it so easy. And finally, who is using these APIs? Developers and developers. They are both tools to be used by developers. So this is my question. Can we get the benefits of both the WP REST API and WP GraphQL at the same time? Yes, we can, and this is what I'm here to show you. Introduction to the GraphQL API for WordPress. So from now on, we're going to start my talk in which I'm going to demonstrate what I have been working on for the last few years and what I'm going to be launching soon. So this is a sneak preview of the upcoming plugin, which will be released in May 2020. So I'm going to first show the features that we have, which are quite distinctive. First one is we have the GraphQL. I'm going to show a demo later on, and you can actually appreciate it. But we have first a GraphQL to show the full schema that you have on your server on your website. Queries are against a GraphQL endpoint with the complete schema and the WP admin. So not everyone can access this GraphQL, only the admin. And in this screen, you can access all the information from the server. Then we have the interactive schema where we can see all the relationships of all the entities in the database. This is what you have, what you get shipped from WordPress. You have posts, you have users, you have comments, you have pages, you have user roles, you have tags, you have categories. All of these entities, you can visualize them. You can see all the properties that they have, and you can see how they relate to each other. And you have all the documentation. Basically, when you're querying in GraphQL, you will be able to fetch exactly the field from the entity that you need. Now, this is where it starts getting more secure. We have custom endpoints. So before, when I was talking about WP GraphQL, I mentioned that they have a single endpoint. This is not a problem from WP GraphQL. This is the strategy employed by GraphQL in general, that you have only one single. Generally, it is /GraphQL, to which you execute your queries. But here, what we have is that you can create multiple endpoints, and on each endpoint, you can attach a different behavior. You can actually limit who can access the endpoint. You can say how it will be cached, how it will be deprecated. We're going to be looking at these things. And the way that it works is this is pure WordPress. This is a custom post type. Actually, everything from now on will be a custom post type, so that there is no difficulty in using. We will see this soon. Next one, we have persisted queries. So once again, the problem with GraphQL is that you're allowing everyone to query the data from your server, anything they want. So we can persist the query that we need and just give access to the query and nothing else. Then we can hide the endpoint. And because the persisted query, it has its own URL, we can even cache it. Okay, so this is actually a combination of both GraphQL with REST. It's really getting the benefit from both APIs. We have schema configurations, which the idea is that we have the big schema. A schema is basically all the entities in our database, all the posts, all the users, all the data that we have. And we may want to expose all the data to everyone or not. Maybe we don't want to. because, I mean, some data is private. We have certain fields which can only be accessed by the team and not by our clients. So then what we can do is to create configurations where we expose certain parts of the schema, and we create a subschema. And we can create as many as we want for as many different targets, clients, teams, anything that we want. We have access control lists in which we can define who can access a field, like every single field, the user, we can say the email, the ID, the name, the first name, the last name. These are the fields, and we can say who has access to each of these fields. And we can set up rules. We can say logged in users can access, users with certain role or capability, or we can create our own custom rules. Then we have cache control lists, in which we can implement, we can define the max age for HTTP caching. So when we are accessing, we're executing the query, each of the fields which are involved in the query will have its own value, its own max age value. And at the end, the response will calculate the overall max age from all the involved fields and give that as a header, as the cache control header. And then we can actually cache this on different layers on the server, on a CDN, proxies. Then we have field deprecation lists, which is we can inform our users whenever the schema has been upgraded, and the information comes on the response to the query itself. In standard GraphQL, we give information about deprecation, saying please don't use this field anymore, use this other field instead, through a methodology of introspection, which is that you have to query a very specific field of the data of the schema to get this information, but not on your usual queries. What we'll actually see here is that this information is proactive. It comes to you constantly as you run the query. So now time for the demo. So I'm going to switch to my next tab, in which, oh, I have been logged out. It's here, WordPress, I think. Oh, I'm still logged in, it seems. No, I'm not logged in. Okay, so here we have a problem. Okay, I don't know this. So I'm going to show you a video. I have recorded a video. This is a video of the custom endpoints, how they work. The URL is on Vimeo. Actually, I should actually check which is my password and try to show you the demo. Give me 1 second. Sorry for this. I was logged out and I don't know the password. How can I? Okay, well, let's just go ahead. I have the videos. I have made the videos. So this is I'm going to show you now the GraphQL endpoints. So we click on a new GraphQL endpoint. And we add the name. Oh, I don't think you have seen the video. This app, GoToWebinar, is not going very well right now. We start again. Okay, there you go. Second. So we click on add new GraphQL endpoint. We add the name of the endpoint. We have all the information there already, and we click on publish. And then we click on the endpoint. And what we see there is that it says the query, the body is empty. And we can access a GraphQL instance that is in where we can execute a query against the endpoint. When we run it, there we have it. We can also see the schema through this client called Voyager. And these are the relationships that we have. This is for our custom endpoint that we just created. Let's just do this. Okay. Now I'm going to show the persisted queries, how they work. So in the persisted queries, what we're going to do is to save a query on our website and only expose the query. So once again, we go to add new GraphQL persisted query. This is a post type. And what we're presented here is pure Gutenberg. We add the title for our custom query, persisted query. We select which fields we want to retrieve. In this case, we say that we want 5 posts. We can specify the offset as a variable, and we will be able to customize the offset later on. We're going to see this how. We say that we want the author. We are retrieving the ID, the name, the comments. We're going to have the content of the comment, the date. The date we can also give it some format, the ID, and then we get the information of the post itself. We want the date, we want the excerpt. We're going to get the feature image, the ID and the source, the title, the URL, and also some tags, just with your name. When we run the query, we can see that we got there all the data. And you can see actually executes very fast. Now we publish the persisted query. Now it's live. And when we click on that link, the URL is the URL that we created just now. And we have all the data, and we can customize through params the offset in this case, and we get new data. So basically, the persisted query doesn't mean that it's going to be fixed. What is fixed is the query, but not the data. We can get new data, different data through parameters that we define as variables in the GraphQL query. Access control lists. Now what we're going to define is who can access every field on our schema. So we have a schema configuration on our endpoint. We're going to go to the access control lists. Once again, this is a custom post type. We just add a new custom post. We add the title. We're going to call it, in this case, personal user data. We want to only give access to users to their own data or to the admin. In this case, the email and the capabilities. We don't want everyone to be able to access these entities. We just say only the logged in users. If you're not logged in, you cannot access this information. It's published now. So once we have created the access control list, we need to add it to the schema configuration. So in the schema configuration, we have one that is called website config. Currently, it doesn't have any information, but we're going to add the access control list that we selected, personal user data. We just update this schema configuration. And we go to the endpoint. And now, when we execute the endpoint, we just click there on view, we go to the GraphQL associated with this endpoint, and we run the query. It works. We have the email. Because I'm logged in, I'm the admin. But now I'm opening a new tab in Firefox in the private mode. I'm not logged in here. And now I will actually do the same query. Users, and for each user, the name and the email. And when we run it, well, we see that the email, we don't get it. It says you must be logged in to access field email for type user, which is what we wanted. We wanted to restrict access to this field. Next one, we're going to see how through an access control list, we can define what I call the public-private schema, which is when it fails, when you cannot show some information to the user because the validation fails, what do? Do you tell the user, sorry, you can't watch this, you cannot see this information because you're not an admin? Or do you say, sorry, this information doesn't exist? The difference between these two is the difference between allowing your users to find out why they couldn't make something, or not even allowing them to know of the existence of the field in first place. So one is indoors, that is private for your own team, for your company. The other one is outdoors for your clients. And what we'll see that from the single source of truth of all content from your schema, you just say, I want this information to be private. We're going to see this in the demo. It's loading the video. Let's wait for a few moments. Okay, there we go. Okay, there we go. So we define which is the fields that we want to validate once again, and we create the capabilities. We say in this case only people with these capabilities can see these fields. We have to wait until the video loads. Okay, and we also say actually, if this takes long, I'm going to show you the video in my computer. Let's do that. Okay, there it goes again. And I only want the admin to be able to access this field. So we first set it up as public, and we update. Now, when we access the query, we run it. First time it works fine because I'm logged in. I'm an admin, so it didn't fail for me. I open a new tab in Firefox. This is private, so I'm not logged in here. When I run it, it says you must be logged in to access field roles. This is what I said just now. I wanted the field to be public. And if we actually check the schema, what we will actually see is that we can access the user role. That was the connection from the entity user to the user role because it's public. Even though it fails, it's actually public. So the connection exists. But now we change it and we make it private. So now if we execute the query, once again, where I'm not logged in, it will fail. But now the error says this field does not exist. And when we see the schema, we can see the user role entity has disappeared. We cannot access it. It just doesn't exist anymore. So now what we have is our full schema or the database on our website. And some information we can say this only belongs to us, the team, and some other information is public and everyone can see that. And you only have to manage one single source of content. Now I'm going to show you one which is one of my favorites, which is the cache control list. And this is one of my favorites because it's very difficult to cache in GraphQL. That's what they say. If you have experience with GraphQL, I would like to ask, do you have experience with GraphQL? With which platforms are you using WP GraphQL in the case of WordPress, or are you using Apollo in the case of JavaScript, or Nexus, or how? And most likely they will say, sorry, no caching, cannot be done. HTTP caching, no, it just doesn't work with GraphQL. What I'm actually going to show here is how easy it is to implement caching, that you can define it on a field-by-field basis. So let's watch this video. Come on. Okay, there we go. So we had already this persisted query, and we are going now to attach a cache control list to the query. It's not worth it that we can only use this with persisted queries, because a query has its own URL, so it can be cached. It doesn't work with a single endpoint. So we create a new list, we call it website CCL, and we define two fields, in this case, the user URL and the post URL, and we set up a max age of 60 seconds. We also create, for a different field, for the title, we set 35 seconds, we want to cache it. And we add another entry, we do it for the user name, and we say that the username will have 22 seconds. And we publish this. Okay, so we publish it now. We go back to the schema configuration, and we attach this cache control list to the schema configuration that we have called website config. We click on the cache control list block, and we select the new one that we just created, website CCL. We update it, and now we go back to our persisted query. We will actually open it on Firefox on a new tab. I'm checking out which is the URL for the persisted query there, and then click to open. Here we go. This is the query so far, doesn't really do much. We toggle the tools to see the response. Hopefully you can see, hopefully it's not going to be very small. So now we run this query with the URL, and we check which is the max age, and what we see there is 60 seconds. Hopefully you can see. I hope it's not so tiny. 60 seconds is what we had defined before. Now we're going to do it the post style. We run the query. We first have to update the persisted query. We save it now. We go back to the Firefox tab, and we execute again the query, and we check. Now the cache control says max age 35 seconds. And finally, we will attach the name for the user, update the query, run it again. Now we have 22 seconds. Moreover, what happens if a field needs state? Me. Me says me, the user who is logged in. In this case, is the admin. So in this case, it should say you cannot cache it because you need the state. We check again. It says no store. So then this is intelligent. It knows that if the user, if the field has any state, it cannot be cached. It will not cache it. It will give you no store. Otherwise, it will give you the cache of the field with the lowest caching value of all the fields involved in the query. This is beautiful. Then we have the field deprecation lists. In GraphQL, we have a way to upgrade our schema, which is to create new fields and to say for the old fields, please don't use this field anymore, use this other field instead. This is called deprecation. What we can do in the GraphQL API for WordPress is to manage this deprecation already through the WordPress user interface. Let's play this video, see how this works. We're loading the video now. It's taking a bit of time. And there we go. So we see this endpoint. We have the URL. We open the GraphQL client. And we have this field called display name, which has a display name. We want to deprecate it. We don't want the display name anymore. We want to use name instead. So we create a new field deprecation list. We give it the name. In this case, we're going to call it updated display name. We select which are the fields that we want to deprecate. In this case, it is the display name from the user and the deprecation reason. Use name instead. And we publish this. There we go. Once it has been published, we need to attach the field deprecation list to our schema configuration. We go back to the website config, the one that we have created for our endpoint. And there's a block called field deprecation list. We click there, and now we can select the one that we just created. We update. Now, when we run this same query, voila, It says field display name from type user has been deprecated, use name instead. So what this is demonstrating is that anyone can use this functionality. Now, in order to run a GraphQL query to deprecate a field, you don't need to access the code anymore. You don't need to be a developer. Any person can actually do it. Any user can do it. This is the WordPress way to make it easy for everyone to use it. What WordPress is democratizing publishing in this case is democratizing access to data, democratizing using an API. We're going to watch one final video. This is how to create an API hierarchy in which you have, as we have said before, you can create different endpoints for different users. You can have an endpoint for mobile. You can have an endpoint for your website. You can have an endpoint for this client or for that client. And many of these endpoints, we have shared properties. So we assign these shared properties through a schema configuration. We create a schema configuration and we attach it to the different endpoints. But we can also create a hierarchy in which a persisted query can have a parent and can inherit the properties of the parent. So for instance, you could say, I want to have a persisted query showing the list of all posts, and it will have a default length. The amount of posts that we want to fetch by default is 3. That's for my website. But for my mobile app, I need 10. So I don't want to duplicate the query. So what I do is I create the query only once, and then I create a child, or well, I can create I can inherit from the query and override the properties. We will see this use case in this video. So now we are loading the video. Bear with me for a few moments. Here we go. So we have this this query. It's called post list, and we want to add the limit through a variable called limit. And by default, we will give it a value of 3 in this case. We run the query. We can see we have 3 records. We update. So okay, and we can actually double check. We execute this persistent query, and we can see the URL is GraphQL query / post list. Now we're going to add a new persistent query. We're going to call it custom, just that. And we select the parent, post list. This is the one that we were editing just now. So I'm going to delete the query. Now it has nothing. And we are going to override the limit variable. In this case, we're going to say 10, and we publish. When we actually execute this persistent query, we have 10 results. We have the same query as before, and we can see the URL is GraphQL Query / post list / custom. So we have a hierarchy. We can actually inherit as many levels down as we want. We have, yay, 30 minutes left. We continue. We have 5 to 10 minutes left, 5 minutes left. We're pretty much there anyway, don't worry. So what do we have so far? This is more. We can achieve more. We can do it better. We can do it faster. And it's easier. We have extra features that I haven't shown you because we don't have time. It's extensible. Directives are the building blocks of the API. So I haven't shown you how to create directives, but directives are extremely powerful. And for this API, for this plugin, and you have the power of the whole architecture, of the whole structure, of the whole API for your own needs. There are no restrictions, there are no limitations. Anything that you want to do, you can literally do it. It's very fast. The queries that you could see in the video, they run really fast. And the reason for that is that I do not use a graph. Actually, this is using a different structure, which is much, it's simpler, it's much simpler, which is actually very nice for developing. As I was saying, very simple, there's no graph structure, there's no need to implement batching. It's very comprehensive, a single source of truth for all content, for all of your applications, for your mobile app, for your website, for this client, for that client, public, private, for your own team, for another team, moderating who has access to what, different cache control, everything that you want to create as an output from a single source. And it's manageable. Anyone can use it, not just developers. I mean, you could see how it was point, click, point, click, point, click. You have the API. It's out there. It's published. So let's see the table that we were checking before, comparing WP REST API and WP GraphQL. And now we have the GraphQL API. Speed, we got it. Security, we got it. Security, that's a very important consideration, which is we have custom endpoints. So when we first install the plugin, there's still not information available. We are still not making any information public in our endpoint, because I know endpoint. We actually need to create our custom endpoint, and only then information starts being public. This is a big win for security. Caching, you have native HTTP caching defined on a field by field basis. Access control, you can define field by field who can access it based on user being logged in or not, user rules, user capabilities, or custom rules. It's very simple, and anyone can use it, not just developers. So through the GraphQL API for WordPress, what can we do? We can do many things. The first one is the easiest one to think of is Gutenberg. Gutenberg right now is mostly using the WP REST API to fetch data, but with the GraphQL API, it makes it much easier. So Gutenberg gets the data through the GraphQL API that gets it through from WordPress. We give it back. We can also interact with APIs and cloud services. Once again, now WordPress needs to fetch data from some service. We can do it through GraphQL API, fetch the data from the service, give it back. And this leads to WordPress becoming the operating system of the web. This is Matt Mullenweg's dream. He has talked about this. He has said that the way to achieve this, as he sees that, is comments and Gutenberg. And I want to add one more, which is access to data. Make it easy to access the WordPress data, because we have now React, we have Vue, we have Gatsby, we have mobile apps. They all want to access data, and they're very good at granting client-side, very nice interface, very fast, very resilient, but not at handling data. As a CMS, WordPress shines, and now through the GraphQL API, it can share this data with all of these different entities. They request the data, we have GraphQL API, you give it back. So now WordPress can become the center of the web. WordPress already is the center of the web, but it can become much more so. It can become the center of the modern web. Pairing Gutenberg with WordPress, with the GraphQL API, and with the whole ecosystem can do wonders. Release date. I don't have a certain date right now. I'm just telling you it's going to be in May, just a few weeks from now. But if you want to find out when it's going to be, there's a Slack workspace that you can join. So just, you can ping on this channel if you're present on this conference. If you're not, you can tweet or direct message me at Losoviz, which is my Twitter handle. One parting thought, GraphQL for everybody. This is democratizing access to data in WordPress through GraphQL. I believe that this is an incredible tool, and we have a possibility to make wonderful things with it. That's it. Thanks. Once again, if you can see, the URL for these slides is slides.com/leoloso/GraphQL API for WordPress. My Twitter is Losoviz. My personal blog is leoloso.com. Now we're open to questions in the Q&A. Thank you.